Okay, we're going to continue with section 10.2. And again, the I can statement was I can compute the probability of simple events. And you'll remember when we talked about this yesterday, we were talking about simple events. They're pretty easy to describe and understand. And really, all we need to know, because we're computing these with theoretical probabilities, is we need to know how many outcomes are possible, and then how many of those outcomes are the ones that we want. Like we wanted to pick a 2 out of this deck of cards, or we wanted a vowel on the spinner or something like that. So as we go through and look at this second part of the assignment, again, we're kind of drawing all these ideas together that we've talked about as far as the basics of probability, and using a lot of different the terminology and the ideas. So here's example 4. It says assign a 0, a 0.5, or a 1 to estimate, and I'm going to underline estimate. These aren't perfect. We just need to come close to the probability for each event. So probability you're in Utah right now. Now, since I teach in Utah and you're in a classroom in Utah most likely, the probability that you're in Utah right now would be 1, meaning 100% probability. This is a sure thing, no doubt about it. Now, on the next one, as much as you'd like this to happen, again, think in terms of how likely is this? Is this really likely? Not very likely? Is this impossible? Is this a sure thing? Well, as much as we'd like this to be a sure thing for pizza to fall from the sky at lunchtime, it's not going to happen. Hasn't happened yet, probably won't ever happen, so that probability would be 0. And then probability you roll an odd number on a die. Now remember, a regular old die has 6 sides. It's got 1 through 6. So odds are 1, 3, and 5. That's half of the 6. So our probability there is going to be 0.5. It's going to be right in the middle. So remember, something that's impossible is going to have a probability that's 0. If it's a low probability, it's going to be, not very common. It's going to be close to 0. If there's a really high likelihood of it happening, it's pretty probable. It's going to have a high probability, something closer to 1. And then this is kind of right in the middle. Yeah, maybe it'll happen, maybe it won't. It's kind of a 50-50. So on example 5, a drawing is being held at a school party. There are 20 prizes in all, so that might be important right there. 20 prizes in all. 7 Sour Patch Kids, 8 Whoppers, and some Pringles. Use what you know about probability to do the following. So the first thing says make a probability model for this situation. So let's list the outcomes. The outcomes are Sour Patch, Whoppers, okay, and Pringles. Okay, and then the probability. Now remember, there were 20, so Sour Patch Kids, there were 7 of those, so that's going to be 7 out of 20. The Whoppers, that's 8 out of 20. Okay, now I'm going to leave it that way. And then the Pringles, well, remember this, these have to add up to be 1, so this has got to be whatever's left. So if this is 7 twentieths and 8 twentieths, that's 15 twentieths. The other one's got to make up the difference, so it's got to be 5 twentieths. The other thing that you could do is you could add these together and realize that that's 15, and we need 20 altogether, so there must have been 5 of those. Now if we want to simplify this, this one's not simple, or that one is simplified. This one simplifies to 4/10. Wait a minute, we can go even further than that, can't we? We can go 2/5, and this one right here would be 1/4. Okay, so we've made a probability model, done that. What's the probability of winning a can of Pringles? Well, the probability of winning a can of Pringles is 1/4. We've got that sitting right there in our probability model. What's the probability of winning Pringles or Whoppers? Pringles or Whoppers? Well, those are these two. Now, if we want to add the 2 of those together, we've got to get a common denominator, which means we're going to make them into 20s, which means they're going to be this right here. Or one way you could do it is you could say, well, let's see, there are 8 Whoppers and 5 Pringles, so that's going to be 13 out of 20, and that's the answer. Or we could just add those 2 probabilities together. 8 twentieths plus 5 twentieths would be 13 twentieths. Okay, on to the next one. Now, this has an asterisk by it, and we've got a spinner right here. Now I want you to notice something about the spinner. This space right here with the 3 is really big. Now we haven't talked about things that aren't equally likely. If this is a fair spinner, not warped or anything weird like that, it's not more likely to land, one place than another. These are not all equal sizes, so one thing that we can do to make them all the same is we could just say, well, look, since that's twice as big, we're going to count that as 2 spaces. So we're going to think of it like there's 2 3s on this. So the first part says, what's the probability of a number less than 3? A number less than 3 would be 0, 1, or 2. So that would be 3 out of 8. So 3/8 would be the answer for that one. And then this one says, what's the probability of a number 3 or less? So 3 or less would be a 3 landing here, a 3 landing here, or the 2 and the 1 and the 0. So that would mean that we've got 5 out of the 8 spaces covered. So that would be 5/8. Okay, the 5, the 6, and the 4, those are the only ones that wouldn't count there. All right. Now, last one we're going to take a look at here might require a little bit of thought. I think this is a good one. If the following table represents the number of brass instruments in the horn section of the Utah Symphony, what is the probability that a horn player selected at random will play the blank? So we're just going to take this brass section and we're going to pick somebody at random, and we want to know in this case what's the probability that they play a tuba. Well, these are all the different instruments and these are their frequencies. So we would want to figure out, well, how many people play these instruments? So let's add these up. 3 plus 1 is 4, plus 5 is 9, so that means 12 total. So we could go through and we could figure out the probability for each one of these. Well, this would be 3/12, 1/12. There aren't very many tuba players, so there's only a 1/12 probability that we're going to choose that particular person. 5 of them play the trumpet, and 3 of them play the trombone. Now, I haven't reduced these because I've just got those sitting here. Here are the outcomes, there are the probabilities. I've kind of got my probability model here, and it just says what's the probability of picking somebody at random who plays the tuba, and the answer there would be 1/12. So we're going to circle that. We're done with that. French horn or trumpet, either one of those are okay. So the French horn or the trumpet. So there are 3 here and 5 here, so that would be 8 altogether, 8 out of the 12, and we'll go ahead and we'll reduce that. 4 goes in there twice, 4 goes in there 3 times, so we end up with 2/3. And then a brass horn that starts with the letter T. A brass horn that starts with the letter T. Well, these 3 all start with T. That one doesn't. So we could just say, well, gosh, if there are 12 altogether, that means these must add up to be 9. So 9 out of 12. Or you could literally just go through and add those up. So that would be 9 out of 12, which we would reduce to 3/4. So as you're going through and doing the assignment, think about these ideas that we talked about today. So think about those simple events, probabilities that are really high, really low, impossible, different things like that, how a probability model is set up, how you can find maybe a missing piece or something like that, and what you can do in a situation like this where one of them, in this case the 3, kind of takes up twice as much space. All right, good luck.